Hello everyone. In this session, we want to take a look at cloning a distributed file system replication database. We also want to look at recovering a DFS database that is corrupted. And we also want to take a look at optimizing distributed file system replication. Let's start by looking at cloning a distributed file service replication database. Database cloning is simply an alternate method of transferring data to a replication partner. In our scenario here, we have server 1 as a primary or upstream server. And let us say that we needed to transfer or replicate data to server 2. So we might have had a number of shared folders on server 1, and we want that exact copy of those shared folders to be on server 2. So we need to precede that data, meaning we need to transfer the data to server 2. Now, Microsoft recommends that we use robocopy, which is Microsoft command line, or we use Windows backup. Instead of simply taking the shared folders and copying them over to server 2. Because when we do a normal copy, then the date and time will be modified. And what we're looking for is an exact copy of the file as it exists on server 1. One would think that server 2, having received a copy of the files on server 1, would then simply take that data and synchronize it with server 3 and server 4, where there are also copies of that share. But it doesn't work like that. Server 2 has to go through a process. And the process that server 2 goes through is that on server 2, every single file has to be scanned and a hash made of that file. The hash for the files are stored in a database on server 2. Now, what happens with the hash is it is compared with the other hash in a database on server 3 or server 4 or any other replication partners. So you will have traffic going up and down, back and forth. For example, I would take a file called file 1, and then server 2 will contact server 3 and say, well, let me see your file 1. Are there any differences between your copy and my copy? And then they would look at the file 1 on server 4. Is there any difference between the files? Were there any changes that were made? And that information would have to go back and forth between the servers. As you can imagine, that would take quite a long time and could be very expensive in terms of network utilization, because that data in the database has to be gone over very carefully. Each file again has to be checked with every other file on the network that is the same. If a change was made, let's say someone made a last change, then that file would be the one that would be synchronized to the other servers. Let's say Jim made a change to a file at 10 o'clock. And then Jenny made a change to that same file at 10 past 10. The change that was made at 10 past 10 is a change that will be replicated to the other servers. And only the changes will be replicated. Because remember, the data goes into a staging folder. And if we're using remote differential compression, only the changes will be synced to the other servers. Our main point here is that the whole process of comparing hashes from different servers took quite a lot of time. And if you had a very large database, and sometimes you have more than one volume on a server, and if you had more than one volume on a server, then you would have more than one database. So there was a lot of back and forth, and network utilization at that point was not optimum utilization. And like I said, if you have a slow, unreliable network, it was even worse. So that is the initial method that was used for the transfer of data or the replication of data from one server to the other. And this was prior to Server 2012 R2. Server 2012 R2 now came up with an alternate method, and that alternate method is called database cloning. With database cloning, the data is preceded from the upstream server to the downstream server, just as it was in previous version of server. But there's a difference here with database cloning. With database cloning, the database is exported from the server and then imported into the target server. So you have here the source server. This database is exported, and this is what we call cloning. So there's a clone copy of that database. And then that clone database is imported into the database of the target server. So instead of only the data, which will be the files being transferred, the database complete with the hash of the files is also transferred to the target server. What this does is eliminates the whole thing about the comparison and the exchange of data between servers that takes place over the wire or over the network between the two servers. Each file is now considered correct because there is no exchange of data between servers. The only exchange that we would have would be the deltas, and the delta then would be only the changes or the new files that were made. This method that we're using with the database cloning will only now examine the changes. Remember, in the previous version, even though the data was sent over to the second server, that server had to do a scan and look at every single file and make a hash of every single file and store it within the database. Now, as you can imagine, if the database is already there with those changes, this cuts down on the time it would take for synchronization to occur. So there's almost now a 99% improvement in synchronization. We now want to turn our attention to database recovery. The database, the distributed file system replication database, can become corrupted. There are many reasons why a database may become corrupted. One of those reasons would be that there is a service failure on the DFSR server. We refer to that as a dirty shutdown. Or there might be a hardware error where the data is not being returned to the disk. In any case, once that database is corrupted, replication is not going to take place. So when a change is made to a file or folder, that change is not going to be replicated to the replication partner. Now, prior to Server 2012 R2, once the system detected that there was corruption with a database, the system would delete the entire database and recreate that database. But the database that was recreated was empty. That meant that all of the files had to then be transferred to that system. The system had to look at every one of the files again, just like the initial replication, had to make a hash of each file and then store it in the database. And we know that that takes a long time, especially where you have a very, very large set of information stored on many different servers. With Server 2012 R2, we have a new recovery method. Very simple method. When the system detects that there is a failure with the DFS database, that it's corrupted, the system will automatically rebuild that database. The files are marked as normal, and the changes then are merged with the replication partners. We recently had a case where our file server ran out of space, and as a result, DFSR was abruptly stopped. So the replication service detected that an unexpected shutdown was on that particular volume. And that particular incident occurred because we had a power failure or power loss. So there was an error on the volume. With Server 2012 R2, we did not have to manually restore that service. The service automatically initiated a recovery process and it rebuilt the database. So no action was required. So that is the new method for recovery for Server 2012 R2. Previously, you had to do a manual restart of the system, and when the service did start, when the database was created, it was empty and had to be preceded and the data replicated all over again. In Event Viewer, you can find the DFS-R replication error ID 22112, saying that the service had detected an unexpected shutdown. And when the service is restored or when it has started successfully again, you can look at error ID 2106 in Event Viewer. To recap, if you are using the recovery process of cloning, then you wouldn't need to wait for the slow process of recovery to complete. You can clone the primary database as described previously and use it to recover the corrupted database. You wouldn't need to precede the replicated folder, so you can skip that step. But You should remove the memberships of the problem server to prevent DFSR from attempting to rebuild the database until the cloning is complete. We want to take a look at optimizing DFSR replication. DFSR can be optimized by tuning the file staging sizes. By optimize, we mean that we need to configure DFS to operate at its best level. And we can do that by trying to configure the size of the staging file. Let us right-click here on the replicated folder, select Properties, and click on Staging. And here we see that we have a default quota for that staging file. Windows Server 2012 R2 gives us the capability to configure the minimum staging size for files in order to increase performance when replicating large files. Now, in previous versions of Windows Server, DFSR used a fixed 256 KB file size as the minimum size for staging. If a file is larger than 256 KB, it is staged before it replicates. Further, if the staging folder quota is configured too small, DFSR consumes additional CPU and disk resources. The staging folder quota should be large enough that replication can continue even if multiple large files are staged awaiting replication. So in order to improve performance, we need to configure that staging folder as close to the size of the replicated folder as possible. What we can do to optimize replication is also try locating the staging folder on a different disk from the folder that is being replicated. So optimizing DFSR is simply trying to put the quota size at a level where it will not be consuming so much disk resources or additional CPU, and we do that by configuring the size of the quota to the best possible performance. In this session, we took a look at DFSR cloning. We took a look at recovery of the DFS database. We also took a look at optimizing DFSR. This is the end of our session, and I want to thank you for listening.